we want to simplify this ratio. And so one way that we could simplify this is to expand. Y to the fourth power means y times y times y times y. X to the fifth power, expanding that, 1, 2, 3, 4, 5. In the denominator, the y to the sixth, 1, 2, 3, 4, 5, 6, and then x squared, x times x. And then we could go through and just cancel any numerator that's the same as any denominator. So let me do that. I have this y with this y, this one, these ones. Okay, so I've canceled all the y's that are the same. Then moving on to the x's, I can have that x with this x with this x. And so all we have left is 1, 2, 3. We have x to the third power. And then we have y times y on the bottom, so we have y to the second power. A shortcut, however, is our quotient rule. And remember, when you're dividing, you subtract exponents. So I would be subtracting the 6 and the 4. So 6 minus 4 is 2. I have y squared. But there are more y's on the bottom, and that's why the y's end up here. For the x's, if I subtract those, the 5 and the 2, 5 minus 2 is 3. But the x to the third power is going to go in the top because there are more x's in the top. So many of you will skip expanding and just subtract your exponents. So let's look at just a couple more really quick. Okay, so this one here, I'm going to jump directly to the answer. Looking at my A's, I don't see it, but there is a 1 in the exponent there. So I'm going to subtract the 5 and the 1. 5 minus 1 is 4. There are more A's in the bottom, so the A to the fourth is going to be in the bottom. Then here, 6 minus 2 is 4, so I'm going to have x to the fourth. And because there are more x's in the top, the x to the fourth is in the top. But worst case scenario, you could list the A, expand out the x to the sixth, the a to the fifth, and the x squared, and then just start canceling this a with this a here, this x, and this x, this one, and this one, and count them up. 1, 2, 3, 4, x to the fourth, 1, 2, 3, 4, a to the fourth. Okay, so last example here. Again, we'll just go ahead and jump to the end and see if we can do this. This one's a little trickier. I have 5 minus 2, so I'm going to have u to the third. There are more u's in the bottom. So I have the u to the third in the bottom. But if you use the rule subtraction here, 6 minus 6 is 0. So I would get v to the 0 power. And you might wonder, like, what does that mean? But anything to the 0 power equals 1. So I end up with 1. So this is a problem where you're like, oh, I'm not sure what's going on. The rule is confusing me. So you might have chosen to expand. U squared is u times u. V to the sixth, 1, 2, 3, 4, 5, 6, over u to the fifth times v to the sixth. And then start canceling all of these out. So here's my u and my u, this one and this one. And then all of these v's, see how there are 6 of them here? All of those cancel and all of those cancel, so they're completely gone. So if all the v's drop out, there's nothing in the top, but there's always a 1 multiplied by something up here. So this is a 1, and then I have 1, 2, 3, so I have u to the third.